Yesterday, we introduced the exponential function. We had a look at its standard form, and we had a look at what each of the components does to the actual graph. We know that for any function, it's fully described as long as we have all the variables except x and y, which are our inputs and outputs. That means that for the exponential function, if I can find a, b, and q, then I've got the equation. Now notice, up until now, we've only needed to find a and q, or m and c for the straight line graph. But today we're going to have to look at finding a, b, and q. So let's just remind ourselves real quick what each of these things represents. So if we have a look at our a, we know that our a represents part of the shape. In this case, we know that if a is greater than 0, then our graph will be above the asymptote line. And if a is less than 0, then our graph will be below the asymptote. B also tells us a little bit about the shape. We know that if b is greater than 1, then the graph will be increasing, so going from the bottom to the top. And if b is between 0 and 1, then we know that it's a decreasing graph. Now, another thing that we need to remember is what q tells us. So just like before, it tells us the vertical shift. I'm just going to write really abbreviated versions here. Don't do this in your stuff. Or more importantly, it tells us the horizontal asymptote. I'm hoping you're getting used to the word asymptote by now. And if not, please go back to our previous videos and check out what that means. So really importantly, A will tell us if it's above or below the horizontal asymptote. B will tell us if it's an increasing or a decreasing function. And Q will tell us both the vertical shift and the horizontal asymptote. So let's keep that in the back of our minds as we go on to the example. We're going to look at two different cases. These are two different ways that they can ask you the question to find an equation of an exponential function. Let's have a look at case 1, where we're given the horizontal asymptote and up to 2 other points. Now what's interesting here is, if you noticed, up until now, it's usually the asymptote and a point, but that's always because we've only had 2 unknowns. Now, in the case of an exponential function, we have 3 unknowns possibly, a, b, and q. So they would need to give you up to 3 pieces of information. Alrighty, so let's get started with example 1. It says, determine the equation of the graph g in the form gx equals b to the power of x plus q if the horizontal asymptote is the line y equals -3 and 2, 1 is a point which lies on the graph. The very first thing I want you to notice is that we were only given 2 pieces of information. Look very carefully. You'll notice that there is no a here. So the a in this case is already given as a 1. So it's 1 times b to the power of x plus q. So we only have 2 unknowns, b and q. So there we go. That's why we only got 2 pieces of information. So let's get started with what I'm hoping is obvious. Because we know the horizontal asymptote, we know the value of q. So we should know that q is equal to -3. So we've used that piece of information. And now what's left is using this piece of information. So let's see, what does our equation look like so far? Well, we know y is equal to b to the power of x minus 3. So I really only need to find b now. If I substitute in the point 2, 1, hopefully we can sort this out. So let's substitute the point 2, 1. So wherever I see an x, I'm going to replace it with a 2. Wherever I see a y, I'm going to replace it with a 1. So 1 is equal to b to the power of 2 minus 3. I'm going to bring that -3 across, and that'll become a plus 3. So 1 plus 3 is 4 equals b squared. Okay, so now if I do this really carefully, I know that b should be equal to plus or minus 2. But stop right there. If you remember correctly, we know that b has to be positive, so this must mean that b is equal to 2. And there you go. You've got your q value and you've got your b value. So now let's write out the equation, because that's what the question wants. So therefore, our equation is going to be g of x or y is equal to, instead of b, I'm going to write 2 to the power of x, and instead of q, I'm going to write -3. Okay, here we had 2 unknowns, the the b and the q, so we had two pieces of information. Let's move on to example 2 here. Determine the equation of the graph below. All right, so here I can see this point over here. I can see that, and I'm hoping you now recognize that this is our horizontal asymptote. But if I look really carefully, I can see another point just there. Because it goes through the origin, I know that this is also the point 0, 0. So let's just write down here our standard form. Y is equal to a times b to the power of x plus q. So one thing I'm hoping that jumps out at you is that q is equal to 1. So that's pretty helpful. That means my equation has already changed to y equals a times b to the power of x plus 1. So let's substitute in some points. We've now used this information, so we've got those two extra points. I'm going to start with the 0, 0 and see what happens there. Okay, so let's substitute in the point 0, 0. So I'm going to say 0 is equal to a times b to the power of 0 plus 1. Okay, I'm going to move this one over. It's going to become minus 1 equals a times, what's b to the power of 0? I'm hoping you remember that that's 1. And so now we can say a is equal to negative 1. Now let's think about this very carefully. We're saying that a is negative, so it should fall below the asymptote line. And if you look back at the picture, it definitely does. Okay, that's a good start. So now we have our a value. So actually now our equation is y is equal to negative 1 times b to the power of x plus 1, or you can just write negative b to the power of x plus 1, because we know that that x applies only to the b and not to the negative. So now we've used two pieces of information, but luckily we still have a third piece of information, which is the point negative 1, negative 2. So let's substitute in the point negative 1, negative 2. Alrighty, so now wherever I see a y, all right, negative 2 is equal to negative, I still don't know b, x is a negative 1 plus 1. Okay, let's get this number over to the other side. It'll become a minus 1. Minus 2 minus 1 is minus 3 is equal to negative b to the power of negative 1. All right, I'm going to divide right through by a negative, and I'll get 3 is equal to b to the power of negative 1. If I remember very carefully, that means that 3 is equal to 1 over b, and that will mean that b is equal to a third. All right, so now I have my a value, I have my q value, and I have my b value, so I can finalize my equation and say, therefore, my final equation is equal to y equals negative 1 times a third to the power of x plus 1. Now, it might take a bit of time to get used to, so let's just go over what we did one more time. We were given three pieces of information. The first one that we used, I'm hoping is starting to become a bit obvious, is when we have the asymptote, that's our q value. So we replaced our q value with plus 1 straight away. Then I substituted in the point that you didn't necessarily see was given, but that was given, which is 0, 0. And there I got negative 1 is equal to a, so I replaced a with a negative 1. And then my only unknown left was b, so I just substituted in the extra point that they gave us, and I got that b is equal to 1 over 3. So there you go. There is my final equation. And we don't forget to write the equation if that is what the question asked us for. So that's case 1. That's where they give us a horizontal asymptote and at least one more point, but depending on the number of unknowns, it could be more than 1 point. Now let's move on to case 2. This is given any 2 points. Now, let's have a look what we see here. So I can see that I've got a point minus 110. I've also got this y-intercept of 2, so technically that would be the point 0, 2, because if we remember, at our y-intercept, x is always equal to 0. Now, something that maybe you would take a second to notice is they haven't given us an asymptote, which must mean that the x-axis is our asymptote. So we actually have an asymptote at y equals 0. If we write our standard form, we've got y equals a times b to the power of x plus q. If our horizontal asymptote is y equals 0, then that must mean that q is equal to 0. So technically, we already know that our equation is going to be y equals a times b to the power of x plus 0, which I don't even have to write. So there you go. We've used one piece of information that you might not even have seen that they gave us, which is the horizontal asymptote. Okay, so let's use the other bits of information. Let's try this y-intercept. Let's substitute that point. So let's substitute the point 0, 2, and we'll see what we get. Well, we've got 2 is equal to a times b to the power of 0. Okay, so let's simplify. B to the power of 0 is 1, and that must mean that a is equal to 2. And a being positive would mean that we would have something above the asymptote, and we can see that we do. Now we've substituted one piece of information, so we've used that one. Let's use the last one, minus 1, 10. So let's substitute minus 1, 10. Now, because we know that our a value is 2, we can actually write our equation as y equals 2b to the power of x, again, plus 0, because we know we've got no q value, or a q value of 0 rather. So we're going to say 10 is equal to 2 times b to the power of negative 1. Divide both sides by 2, you're going to get 5 is equal to b to the power of negative 1. And I'm hoping you remember from the one above that this is 1 over b, which would mean that b is equal to 1 over 5. Now, if b is a fraction, it would mean that our original graph was decreasing, and it was. So we can be comfortable that this is the correct answer. So we just show our markers this all together, and we say, therefore, the final equation is y equals 2 times 1 over 5 to the power of x plus 0. I don't know if you've noticed, but while it looked like they just gave us 2 points, they actually sneaky also gave us a horizontal asymptote. So just be aware of that. Okay, let's move on to example 4. It says, determine the equation in the form y equals b to the power of x plus q of the graph that passes through 2, 5, and 1, negative 1. Now we can see that we only got 2 pieces of information. We've just got these 2 points. No asymptotes, nothing like that. But if we look very carefully, we're only looking for 2 unknowns because the a has been given to us as 1. So let's substitute. Let's see. Let's substitute the points we have and see what we can see. So let's substitute the point 2, 5, and we get 5 is equal to b to the power of 2 plus q. Okay, let's substitute the next point, 1, negative 1, and we're going to get ourselves negative 1 is equal to b to the power of 1 plus q. So let's solve these simultaneously. Let's label this one number 1. And here, instead of writing it like this, I'm going to set it as q is equal to. So I'm going to say q is equal to minus 1 minus b if I take that b over. Okay, so let's make that equation 2. Let's substitute equation 2 into 1. So this, again, is your simultaneous equations, just this time around. I'm using the substitution method instead of the elimination method. The reason I chose to do that is because here I have a b and here I have a b squared. So it wouldn't necessarily be as clear cut as it was before. It would still work, so don't panic. So now I've got 5 is equal to b squared, and wherever I see a q, I'm going to replace it with minus 1 minus b. Okay, so if I simplify this, I'm going to get 5 is equal to b squared minus b minus 1. Let's bring everything over to one side. I'll get 0 is equal to b squared minus b minus 6. Now we have a quadratic, so we're going to have to factorize. So 0 is equal to, we open up our 2 brackets, and we pop down a b, and we think about our factors. So I know it's going to be minus 3 plus 2. If you're having trouble with factorization, please just let me know, and we can go over that outside of our lesson. Okay, so now b minus 3 must equal 0 if we go back to our quadratics, or b plus 2 must equal 0. So this means that b is going to equal 3 or b is going to equal to negative 2. But if we remember really carefully, we know that our b cannot be negative. So this is not applicable. Okay, so our answer is going to be b is equal to 3. Now that I know b, why don't I just substitute it into equation 2? And we're going to get q is equal to minus 1 minus 3, which is equal to minus 4. That means I have my b value and I have my q value over here. So I know my whole equation is going to be y equals 3 to the power of x minus 4. Okay, guys, I know that this last one was a bit trickier, but I'm hoping that it's starting to become more familiar. When you're given 2 bits of information and you can't really use them on their own, like before we could use the horizontal asymptote to find q, we just substitute each of the points in and we solve simultaneously. Now, there is something that I want to discuss with you that isn't part of these examples, but that sometimes creeps up when you're doing questions. You might get something like this: y is equal to 3 times 2 to the power of negative x plus, I don't know, 4. What I really want you to focus on is this negative x. The standard form is to the power of x, not to the power of negative x. I just want to look specifically over here. 2 to the power of negative x. How could we write it as something to the power of x? Well, I'm really hoping that you remember from your exponential rules that this is the same as saying 2 to the power of negative 1 all to the power of x. And 2 to the power of negative 1 is just a half to the power of x. So technically, this equation over here is exactly the same as writing y is equal to 3 times a half to the power of x plus 4. So if you ever see something to the power of negative x, remember this rule. Don't let it trip you up. Okay. All right, guys. Now it's your turn to practice. Good luck, and let me know if you need any help.